Okay, this is lesson 6.1b, and this is maxima and minima word problems. And in these examples, our goal is going to be to write an equation that we can convert to vertex form so we can get the vertex, and then interpret that vertex as a maximum or minimum in the context of the word problem. So we're going to give 4 different types of word problems a shot. We have a revenue example, a number example, an area example, and a graphical example. So we're going to work through all 4 types. First type is revenue. Jeremy works at the Total Candy Superstore where they charge $4 for an extra large bag of chips, and he sells 120 bags per week. He discovers that if he decreases the price by 50 cents, he'll sell 20 extra bags. What price will Jeremy maximize his chip sales? So in order to do this question, we have to understand a couple things. First, we want to maximize. So whenever you see the word maximize or minimize, we are trying to complete the square and find the vertex. But we don't have an equation, so we need to build one. A revenue equation has 2 parts. Your revenue, in words, is always going to equal your price times your amount sold. So, in order to come up with an equation for revenue, or R, we need to write a little mini equation for price, and we need to write one for amount sold. So in your questions, you're always going to have information about price and information about number sold. So let's look for price information. It says they charge $4 for a large bag of chips, and every time they decrease the price by 50 cents, he sells more. So our price is $4 minus 50 cents every time they decrease the price. That's the variable. So if they decrease it 1 time, it's 1 50-cent decrease. If they decrease it 2 times, that's 2 50-cent decreases. 3 times, 3 50-cent decreases. This is why it's your rate of change. Your 0.5 is your rate. So rate always comes with a variable x. What's x? Well, let's say let x be the number of price decreases. So if we decrease the price once, our price would be $3.50. So we have now a little mini equation for price. We can do the same with amount sold because there's 2 pieces of information about amount sold. It says Jeremy will sell approximately 120 bags per week, and he'll sell an additional 20 every time they increase the price or decrease the price. So the amount sold equation is start with 120 and add 20 every time we change the price. So the 20 is our rate. We're going up by 20 for every price decrease. So now we have a price equation and an amount sold equation. For all these revenue examples, they're going to be done the exact same way. You're going to write a price equation and an amount sold equation. Price, always starting price, plus or minus your rate of increase with a variable. Amount sold is always the same. How many we're selling currently, plus or minus how many we'll sell if we change the price. So now that we have a revenue, a price and an amount sold, we can take these and make them revenue. Price, I'm going to put it in brackets, is 4 minus 0.5x. And amount sold, I'm going to put in brackets, is 120 plus 20x. And now we have an equation. And if we take a careful look at this equation is a quadratic equation because we have an x and an x. We have 2 x's. And if we FOILed this out, we'd have an x squared term. And since we have bracket times bracket, we're in factored form. So we have a quadratic in factored form. We don't want a quadratic in factored form. We want a quadratic in vertex form. So we need to be able to get to vertex form. And this is where we need to understand how to change forms. Well, there's 3 forms. there's, where should I write this? I'm going to write it on a scrap piece of paper. Bear with me for a second. There's 3 forms. Let's put standard in the middle. We'll put vertex up here. And we'll put factored right here. So how do we convert forms? Well, we just learned in the last lesson that if we want to go from standard to vertex, we have to complete this square. That's how we get to vertex form. And in that lesson, it also said that if we're in vertex form and we want to go back to standard, we can do that by expanding, which is foiling or using the distributive property and collecting like terms. Now, in the last unit, sorry, in unit 4, actually, no, unit 5, we learned how to go from standard to factored, and that was by factoring. Well, if we want to go from factored to standard, we do it the same way as going from vertex to standard. We expand. So we have factored form and we want to get the vertex, so we want to go to vertex form. So how do we do that? Well, we have to first go to standard form by expanding. And then from standard form, we have to go to vertex form by completing the square. So if you're in factored form, you have to actually take 2 steps. You have to expand first to get to standard form, and then you have to complete the square. So that's what we're going to do in all of these examples where we end up with factored form first. Expand, then complete the square. And there's a picture of this flowchart on the class website. But if you want to add that to your notes, that might be useful, switching forms. All right. So we've got factored form. We're going to expand. And to expand, we're going to FOIL. So how do we FOIL? Well, first, 4 times 120 is 480. That's that one. 4 times 20 is 80, and it's 20x, so it's 80x. Negative 0.5 times 120, that's like multiplying by half or cutting the number in half, would be negative 60x. And negative 0.5x times 20x, well, x times x gives us x squared. Negative times a positive gives us a negative, and half of 20 is 10. Negative 10x squared. So I'm going to collect like terms, and I'm going to put these in an order that's more familiar. I'm going to put the x squared term first, negative 10x squared. I'm going to collect these 2 terms, so we've got 80 minus 60 is 20, and 480 goes on the end. And now we're in standard form. So now we have the revenue in standard form. So we started in factored, and we went to standard. And we did that by expanding. And now we're going to go from standard to vertex. And we're going to do that by complete the square. All right, so let's complete the square. Group the first 2 terms. Common factor what's in front of x squared, so negative 10 comes out of the bracket. 20 divided by 10 is 2. Positive divided by a negative is negative, so we got negative 2x plus 480. Now we take this negative 2, we divide it in half, and we get negative 1, and we square it, and that gives us 1. So the number we're going to add and subtract is 1, plus 1 minus 1. And outside we have 480. Now it's this negative 1 we don't want, so we bring the negative 1 out of the bracket. To do that, we have to multiply by the negative 10. Negative 1 times negative 10 is positive 10. And now we're almost done. We're going to factor that bracket and collect these like terms, which is 490. And how do we factor the perfect square trinomial? Well, we square root the first term, x, sine from the middle term, negative, square root the last term, 1. And there we have it. This is our vertex form of our quadratic revenue equation. We went through all three forms there. So what does this tell us? Well, we have a vertex, and our vertex is 1, 490. So the question is, what does this represent? Well, our equation is about x's and r's instead of x's and y's. So this is an x and that is an r. R stands for revenue and x stands for number of price decreases. So let's come up with a conclusion. Therefore, one price decrease will, the question says, maximize. And if we look, our parabola would open down. So we'd have a maximum as our vertex. We'll maximize revenue at $490. The question says, what's the price? Well, we can just use our price equation. Price equals 4 minus 0.5x. We just found our x was 1 price decrease. So we got 4 minus 0.5, which is 350. So therefore, the price that maximizes revenue is 350. That's a lot of work. But that's how we get there, and that's how we interpret our vertex. Our vertex is always an x and a y, and if you just look at the equation you wrote, in the spot of y is r stands for revenue. In the spot of x is an x stands for number of price decreases. And if you model all your revenue questions just like this one, it'll work out nicely every time. All right, let's try part 2. Find two numbers whose sum is 40 and whose product is a maximum. All right, so what do we got here? Well, we got two numbers. So our two numbers are, let's call them x and y. So let x be first number and y be second number. So the sum is 40. So that means x plus y equals 40. We know this. And product is a maximum. So we want to find the maximum product. Well, product means multiply. So product would be x times y. Now we can't complete the square on this because this isn't something that has just one variable. It has two variables. But we can use this piece of information to replace one of these letters. So let's isolate for y by moving x to the other side, and now we can replace y with 40 minus x. And now we have a quadratic in factored form. So we can do the same as the last example. We can expand and collect like terms. So let's multiply both of these terms by x. We get 40x minus x squared. If I rewrite this, it's minus x squared plus 40x. And there's my standard form. Now we just have to complete the square. Group the first two terms. There are only two terms. And common factor the number in front of x squared, which is negative 1. Then we take the second term, we divide it by 2, which gives us 20, and we square it, which gives us 400. And we're going to add and subtract it. Now we're going to take the last number, the negative 1, out of the bracket by multiplying by a negative. And that gives us plus 400 on the outside. I'm going to finish this up here. Our product, we got a negative. We've got a perfect square trinomial in a bracket, and we have plus 400 on the outside. So how do we factor the perfect square trinomial? Square root of the first term, x, sine from the middle term, negative, a square root of the last term, 20. And now we have no vertex. Our parabola is going to open down, so that means we have a maximum. Our vertex is going to be 20 for x and 400. So what's x? Well, x is the first number. So therefore, if the first number is 20, we found in the spot of y is product, the maximum product is 400. The question asks also, what are the two numbers? Well, the maximum product's 400. The first number is 20. The second number is, we have this equation right here, 40 minus x. X is 20, so it's 40 minus 20. The second number is also 20. And if you want to show your work for that, it would be y equals 40 minus x, which is 40 minus 20, which leaves us with y equals 20. There we go. We just maximized a number problem. Let's try an area question. A rectangular field bounded on one side by a lake is to be fenced in on 3 sides by 80 meters of fencing. What dimensions will produce a maximum area? All right, so let's draw this. We got a length, and we've got a field. We've got 80 meters of fencing, so that's a perimeter, so 800 meters. And we've got 3 sides, so we've got 2 widths and 1 length. So that means our perimeter is going to be just adding the 2 widths and the length. And our perimeter is 800. So we have this equation here. But what we want to do is we want to maximize area. Well, how do we do that? Well, we have to write an area equation. Area of a rectangle is just length times width. But now we have the same problem that we had in the number example. We have 2 different letters. So we have to use our other piece of information to eliminate one of those letters. Well, we can do that because we can isolate one of these equations for either W or L. Let's try L. Move the 2W to the other side, and we get 800 minus 2W. And that we can use here for L. 800 minus 2W. And now we have a factored form of our quadratic. We can expand and complete the square to find the vertex. So let's do that. Distribute the W in, we get, and write them in the other order, negative 2W squared plus 800W. And now to complete the square, we group the first 2 terms, common factor the negative 2, Now, it's key we don't common factor the w as well, just the number in front. And then we take this 400 divided by 2 and square it. Well, divided by 2, we get 200. If we square 200, we get 40,000. So negative 2, w squared minus 400w plus 40,000 minus 40,000. We're going to bring the negative 1 outside, so negative 40,000 times negative 2 is 80,000. And now we can just complete or factor the perfect square trinomial. Negative 2 bracket, it's going to be squared, and we have 80,000 on the outside. So how do we factor again? Square root the first term, we get w. Sign from the middle term is negative. Square root the last term, well, that's 200. And now we have vertex form. And this was standard. So what's vertex form tell us? Well, vertex, again, we're negative. So we have a maximum. Our vertex is 280,000. In the spot of the x is w, so that's a width. In the spot of the y is an a, which stands for area. So the width that gives us the maximum area is 200. So what would the length be? Well, we could solve for that. Over here, our length would be 800 minus 2 times 200, which is 800 minus 400, which is 400. That would be our length. This would be our width. Therefore, the dimensions 200 by 400 meters produce max area. It doesn't say what is the max area. It would be 80,000 meters squared. It says what dimensions? Well, 200 by 400. And all the area maximization questions will work out the same way. You'll be given information about perimeter. You use that to write an expression for either length or width. You write area equation, replace one of the letters, and you're off to the races completing the square. Okay, last example. This will be your favorite. That's not sarcasm. Path of a ball. The path of a ball is modeled by the equation y equals negative x squared plus 2x plus 3, where x is the horizontal distance in meters from a fence, and y is the maximum height above the ground. What is the maximum height of the ball, and at what horizontal distance does it occur? It's just asking you for the vertex. So let's find the vertex. Negative x squared plus 2x plus 3. Since this is negative, we know our parabola is going to be opening down, so we are going to have a maximum, and it just wants to know the maximum height and the horizontal distance. So the maximum height of the ball will be the y of the vertex, and the horizontal distance will be the x of the vertex, because it says x is the horizontal distance and y is the height. Maximum means vertex. So here we go. Group the first two terms, common factor the negative. Take that middle term, 2 divided by 2, which is 1, square it, we get 1, so we're going to add 1 and subtract 1. We're going to take the negative 1, bring it out of the bracket by multiplying by the negative 1 in front. We get 3 plus 1, which is 4. And now we just have to factor the perfect square trinomial. How do we do that? Square root the first term, which is x, sign from the middle term, square root the last term. And there we have vertex form. I'm going to come up with a scale here so we can do a sketch. our vertex is 1, 4. So to answer the question, the max height is the y from the vertex, so 4 meters at 1 meter horizontal. So that means if after 1 meter, it'll go 4 meters in the air. All right, let's do a little sketch of this. To do that, all we're going to do is we're going to use some features of a parabola. We know the vertex, so we're going to plot the vertex. For my scale here, I'm actually going to go up by quarters on the x. So that's quarter, that's half, that's 3/4. That'll be 1. So 2 would be there, and that would be 0. And for my vertical, I'm going to go up by halves. So we got 1, 2, 3, 4. So what do we know about this parabola? Well, we definitely know the vertex is 1, 4. So I'm going to start there. Do we know any other information? Well, we know it opens down. And from standard form, we know the y-intercept is 3. So we know we're starting at 3. We also know that the axis of symmetry goes through the vertex. And we can use the axis of symmetry to find other points. For example, if we have a point on one side of the axis, we can count to the other side and find a similar point. So we've got 1, 2, 3, 4 spaces. This point's away. So on the other side, 1, 2, 3, 4, there'll be another point. And we can use these 3 points as enough to come up with our sketch. We know the ball starts here, goes to a maximum, comes back to 3, and it keeps falling. Where it ends up, doesn't matter. That's our sketch. All right, that's it for 6.1 Part B, where we do applications of finding the vertex. So maximum and minimum word problems. Thanks for watching, and I'll see you in 6.2.